Hello, my dear students. Please subscribe our YouTube channel for more free video lectures and click on bell button for notifications and visit our website to purchase full course.
Hi friends, welcome back to the session. So last session we were discussing about hardware media which are playing a role at different layers. We discussed about repeater and the hub and the switch. Now in this session we will learn about bridge. What is the specialty of a bridge? Point number one, it is also a layer 2 device. It is also intelligent device. When I am talking about intelligent, immediately you need to see that it maintains MAC table. Fourth point, it is used to combine two or more LANs. Next point, bridge must not contain loops. And the next point, bridge uses spanning tree. Next point, every bridge is given number. A least numbered bridge is a root. Remaining are non-root bridges. This is a point. Okay, what is an idea? So whenever I say there is a LAN 1 which it would like to communicate with other LAN 2, just to use the bridge concept. This bridge is used to combine the LANs. You see the beauty of bridge now. This bridge maintains MAC tables. And the next point is, if this is hub which is integrated with bridge to this hub, he is asking how many collision domains in bridge. The answer is 2. Why 2? This is a one collision domain because I am using hub. This is another collision domain because I am using hub. So both are available in the bridge. The same question if I ask switch and a switch which has 10 ports, if both are combined using a bridge, now which has 20 collision domains? Okay friends, Just copy this. Yeah, friends, come to the point. So we were discussing about MAC address. In switch also we observed that there is a MAC address. In bridge also we observed that there is a MAC address. What is the meaning of a MAC address? When you talk about the MAC address, it is also known as Ethernet address. It's also known as hardware address, also known as physical address. It is 48 bits hexadecimal format, 8 octets. Okay. When you take 48-bit address, like this you will get. So here every octet is separated by colon. So 6 octets, and here we have, for example, I say AA, 2 hexadecimal digits. 2 hexadecimal is nothing but 8 bits. Here also, for example, B0, this is also having 8 bits. So how did you get 48 bits? This is one hexadecimal, this is another hexadecimal. Therefore 6 octets into 8 bits, you will get 48-bit address notation. And one more important point is that bridge is unique address in the world. So that means whenever you talk about the MAC address which is there with the bridge, then that MAC address is unique in the world. That's the meaning. So when you talk about the MAC address which is assigned to a switch, which is assigned to a bridge, whatever it may be, then that MAC address is unique. So MAC address is unique. And next point is MAC address is for source and MAC address is also for a destination. This is how about MAC address, and this address is chipped into Ethernet. Okay, this is about the MAC address, and the last important point here is that MAC address is changed at every visiting router. Okay, so what is the full form of MAC? Medium access control. Okay friends, just copy this. Yeah, well friends, now let us look at into next device, that is router. So when you talk about a router, it is a layer 3 device. Okay, it is software and hardware based. The next point is router can at layer 3. When I say layer 3, it works with layer 2 as well as it also works with layer 1. So layer 1 it acts like a link to link, and layer 2, it acts like a MAC address. Layer 3, it acts like a IP address. So router deals with a IP address. And the next point is IP address is not changed during data transmission. But IP address can be assigned or changed regularly when it is not in during data transmission. What I mean to say is packets. I'm talking about a packet. Packet source address and destination address cannot be changed during data transmission. But IP can be assigned or changeable. IP can be changeable at every node. But you see, during a data transmission, the packets, source IP and destination IP must not be changed. I'm talking about packet here. And the next point is router is a public device, also known as WAN device. Next point, router performs NAT, network address translation. So router performs also routing. The routing will give you shortest path. This is another important point. So what is the diagram I shown you in the morning? So that is, router is used to integrate LANs. That's why I said a router can also be called as WAN device or can be called as WAN device. Just copy this. Yeah, well friends, now let us see it's a diagrammatic representation of a router. How router is going to, so last session we understand like this. There is a one LAN and there is other LAN are trying to communicate with the help of router. And now you see, for example, LAN 1 is 802.3, LAN 2 is 802.11. This is a MAC, this is a wireless. My question is, can router able to combine? That's my question. Can router able to integrate those two LANs, or can router able to combine? Is it possible? So for that, our answer is, can router able to combine LAN 1 comma LAN 2? The answer is no. Why no? Because they are different forms. My next question is, 802.3 LAN 1, 802.3 LAN 2. Can you able to communicate with the help of a router? Of course. Can you able to combine? The answer is yes, because both are same forms. So what is the meaning of that? Is router is not a protocol converter. That's very important thing. Router is not a protocol converter. Now my idea is, whenever you talk about the router, so there is a router exist. This is going to be network layer, it plays important role. Data link layer, it plays important role. Physical layer, it plays important role. Which means the router works here, the router also works here, and finally it also, and data link layer and physical layer. So whenever it is a layer 3 device, it automatically works with layer 2 as well as with layer 1. Okay friends, just copy this. Now let us see the next device is gateway. When you talk about the gateway, it is similar to router, except that it can combine 802.x to 802.y anywhere to anywhere. That's why it is known as protocol converter. So simple, it is software and hardware based. It works with application layer. When I am talking about application layer, immediately you need to strike that it works with the downwards layer till it reaches to physical layer. Okay. So what is an idea? I am having 802.2 and I want to go for 802.11. So can I able to do combine those two using a gateway? Can we combine? Answer is yes, because we are using what? Gateway. Any format to other format, it can able to do combination. That is the concept of gateway. Okay. So the last, I think so you got the difference between gateway and router. If it is a concept of a router, it cannot able to do, because router can do same format to same form, LAN integration can be done. But in the gateway, any format to any format the gateway can do. And the next device is router. The router stands for bridge plus router. So it is layer 3 device, can work as a bridge as well as can also work as a router. Okay, just copy them. Yeah. Well, friends, now let us look at into last device, that is firewall. So it is application layer device. It is used to protect network from intruders or other networks. It is software and hardware based. Once again, you see, whenever I say it is application layer device or it is a 7-layer device, it works with application layer 2 once again with the physical layer. Don't forget the stack. The stack is very, very important. And the next one is firewall has the following types. Number 1, application level gateway. Number 2, proxy level gateway. Number 3, circuit level gateway. These are the 3 gateways of firewall. So what is the main intention of this firewall is, this is your corporate network. These are other networks. It would like to enter into our networks. Before they enter into our networks, they have to satisfy some firewall policies. This is your firewall. If policy is not satisfied, then request is denied. This is how we can able to protect our network from intruders with the help of firewalls. So here I can give other diagram. Here is, this is our network and here firewall is there. This is router. They are intruders. Before they come, so they can come up to router, but when they try to enter into firewall, the firewall is going to deny the request which is coming. This is how the firewall is going to protect our networks from intruders. Okay friends, copy. Yeah, well friends, now we will look at into some of the statements here. What is a bit rate? What is a baud rate? So when we talk bit rate, so number of bits per second known as BPS. What is the meaning of baud rate? Number of signal changes per second. This is baud rate. Now, what is a bandwidth? These are all the important questions you must know as your communication student. Bandwidth is in principle capacity this is in the form of bits per second, or you can say bytes per second. And the next one is in the form of throughput. This is actual capacity of channel, which is depends upon link efficiency into bandwidth. This is about throughput. So what is the link efficiency? This is useful time divided by total time. This is about link efficiency. Now, if you take organization of layers with the hardware, now you see, if I am talking about the repeater, how the diagrams look like: application, transport, internet layer, and data link layer, and physical layer. The repeater only works at the physical layer. Remaining, we don't worry. When you talk about a hub, same. Application dot dot to it doesn't mind, but it only deals with the physical layer. There also physical layer, but rest of the layers are not been interacted. The rest of the layers interacted, or they no way concerned with your hubs. Just copy this. So next, when you talk about switch, so application layer, they don't mind. Transport layer to transport layer, you don't mind. Internet layer, don't mind. But once you talk about the data link layer, it deals with a switch. Because it is a layer 2 device. The same story is for bridge also. If you go for router, so application layer, transport to transport presentation session, we don't mind. Internet layer, and now the router takes care. Data link layer is also router takes care. And physical layer is also router takes care. So when I am talking about a firewall or gateway, now see, all the layers are in the stack are responding. So application layer and application layer, firewall or gateway. And down the layer, everybody is going to involve. This is how about router and firewall and gateway. So now we will look at into why OSI is outdated. Why OSI is failed? Due to redundant functionalities. Okay, so that's why TCP/IP is implemented. It's a practical model. Given by IEEE. It's a 4-layer structure. As we know, 4 layers: host to host. There also application, transport, internet layer, host to host. Rest of the things are same. Okay friends, just copy this. Now we see about layer addressing mechanisms. So as far as TCP or IP concern, application layer, transport layer, internet layer, host to host layer. This is compressed with the three layers: application, presentation and session. This is compressed with data link layer and presentation layer. So layer 4, layer 3, layer 2, layer 1. This deals with application address known as app address. Nothing but URL, Uniform Resource Locator, or Universal Resource Locator. It deals with the port address. What is a port address? You need to know about a socket address. What is a socket address? Transport layer deals with the socket address. The socket address consists of two parts. One part is IP and the other part is port number. IP is 32 bits, port number is 16 bits. Therefore, your total socket address is 48 bits binary. Okay. And one more thing is that socket address must be unique. Which is nothing but 1:1. So when you talk about internet layer, it deals with the IP address. As we know, IPv4 and IPv6 is 128 bits, 32 bits. And this deals with MAC address. Already I gave you in the previous lecture its notation and all. MAC address is 48 bit, 6 octet hexadecimal form. This is about addressing mechanism. And when you talk about TL, which has the TCP and UDP, when you talk about IL, which has Internet Protocol, ICMP, IGMP, ARP, Address Resolution Protocol, RARP. This is a completely protocol suite of your internet layer. Okay. So, what is ICMP stands for? ICMP, Internet Control Access Protocol. What is IGMP? Internet Group Message Protocol. What is ARP? Address Resolution Protocol. So what is RARP? Reverse Address Resolution Protocol. Copy this, friends. So very important this is. What is a port address or what is a socket address, and what is a IP address, what is a MAC address, what is application address. Well friends, this is the end of the layer structure. So for the layer structure we discussed about OSI as well as transmission control protocol over IP, internet protocol. In the next session we will see about IP addressing and protocols. Okay friends, so here TCP stands for Transmission Control Protocol over Internet Protocol. So stay tuned to us to get acquainted with IP addressing and the different kinds of protocols. These protocols we will discuss in the next sessions. Thank you very much.